GM. We're gonna talk about stablecoins. You know, one thing I love about stablecoins is how simple they are. It's actually a very simple concept to grasp. So how does a simple stablecoin work? Okay, we're gonna start by, we have the actual stablecoin, which is in the ERC20, right? It's a made up thing. We could call it SHAF USD, SHUSD, or whatever. This is our stablecoin. And the stablecoin has two interesting functions. It has mint and it has burn. Mint to mint new SHUSD, burn SHUSD. What's special about this function is obviously not anyone can call those. Otherwise you wouldn't have a stablecoin for very long. So you have another contract, which I personally like to call the manager. You have a manager contract, and the manager contract keeps track of state, right? So the manager contract knows how much you minted, how much collateral you have, and so on and so forth. What's collateral? Okay, so you need to put in value into the manager in order to mint against it. So that collateral could be anything. Could be ETH, could be wrap BTC, CBBTC, or whatever you want it to be. The important thing, and actually the most annoying thing about stablecoins, is you need an oracle. You need an oracle to tell you how much is your collateral worth in terms of USD, right? So oracle is like ETH is worth 4K. You need that. And I would love if we had a stablecoin that didn't have an oracle, but we currently don't. So this is how most or all stablecoins work. They have an oracle. So the manager has a couple of functions in here. They have a deposit, they have a withdrawal, they have burn, they have liquidate, which is a very interesting function, and they have give me the current collateralization ratio of a user or of an address or whatever, right? So let's say you want to mint some of SHAF USD. You would go into the manager and you would deposit, let's say you would deposit $100 worth of ETH into the manager, okay? So now you have $100 worth of ETH. Actually, let's do 150, which makes this a little bit easier. $100 worth of ETH. And what you can do now is you can call the mint function. So there's a mint function in here. So mint function looks at your collateral and allows you to mint a stable coin against that. So the question would be, small question would be, how much can you mint? How much can you mint now? And this is determined by the collateralization ratio, collateration. So let's say you have $150 worth of ETH and $150, and you want to mint $100 against that. So the way to calculate the collateralization ratio is very simple. You take the value. You take the value of collateral and divide that by the value of stables against that. So in this case, it would be 150%. 150%. Okay? So what does that mean? If you increase the value of the collateralization ratio goes up. So if it's $160, it would be 160%. If you mint more stables, your collateralization ratio goes down. And this is a very, very important concept, is all protocols have a collateralization minimum. So for example, our protocol could have a collateralization ratio minimum of 120%. 120% minimum. Which means you can mint stablecoins up to that amount. We're at 150 now, which is fine. But what happens if the value of ETH goes down? It's at 4K now, goes to 3K, 2K, or whatever. You're going to be fine until you're under this 120%. Because what happens then is anyone can liquidate you, which means they can put in $100 worth of stables and get $120 worth of collateral. And this is very important because it's an incentive to liquidate people, which keeps the protocol healthy. Because if you cross 100% collateralization ratio, it's over. It's over. Goodbye. It's gonna depack, whatever. Because your stablecoin is gonna be under collateralized. You don't have enough collateral to back your stablecoin. So this is the liquidation function here. And liquidation function is very simple, just checks, is this user under the specific collateralization ratio? If yes, you can liquidate. If no, you cannot do anything. And we're gonna look at the implementation in a little bit. So what else is in here? You can withdraw, which means you can withdraw collateral. If you're over that collateralization ratio, it's like you're at 200%. Why? It's like wasted opportunity cost, right? You can take your collateral out and put it somewhere else. I don't know, put it in an oven or something, get 5% or whatever. Burn is for actually burning the stable, which would increase your collateralization ratio. It's like, hey, I'm very close to 120%. Let me give back some stables. Let me pay back some stable coins in order to increase my collateralization ratio so I don't get liquidated and lose my collateral. And you can build fancy liquidation mechanisms where the user keeps some of the collateral and so on and so forth, but that's like the fundamental concept of how it works. Cool. So if we look at the implementation, I have this microstable world repo where there is the most simple possible stablecoin in every language. So if we look at the Solidity one, let's look at microstable, 75 lines of code. You have the SHUSD contract, which is an ERC20 contract, and you have two functions, mint and burn, and mint and burn calls the ERC20 mint and burn. That's it. But it's gated by the manager. And the manager is down below here. And by the way, this is it for the ERC20. There's not more. That's it. So the manager keeps track of address to deposit, how much you deposited in collateral, how much you minted, and it has an oracle. Chainlink oracle or whatever you want to use. In this case, it's using wrapped ETH, so you'd need a ETH oracle. So then the functions, you have deposit, you have burn, mint, withdraw, liquidate, and the view function to get the current collateralization ratio. We talked about all of these, and again, super simple. Deposit is, you put in an amount of wrapped ETH, you increase the address to deposit. You burn the amount of stables, you decrease address to minted, which keeps track of how much you minted. You mint increases the address to minted and also checks if you're over the collateralization ratio. Because if you're under it, we don't want you to mint more stables. Pay back some of your debt before that. Withdraw is to withdraw some collateral, so it decreases the address to deposit. And again, we don't want you to withdraw collateral if you're under the collateralization ratio, so we have the same check here. Cool. So if we look at the collateralization ratio implementation, it gets the amount minted, and it does this simple arithmetic here, which is address to deposit, which is your collateral, times the latest answer of the oracle, and we divide that by the amount minted, which is this thing here. So then the liquidation function is, again, liquidation is permissionless. You're gonna burn the whole collateral of that user, and you're gonna get all the collateral that's in here. And then we reset address to deposit, address to minted for that user. Again, the liquidation function could be fancy. You could have partial liquidations where you only pay some of its that. This is like a total liquidation where you liquidate everything just because it's an easier implementation. And that's basically it for a stablecoin. We also have, if you like Viper, I know a lot of Viper guys out there. Same thing, but in Viper. But we also have Solana implementations where you will... Actually, who did the Yule? Coffree. Thanks, man. That's pretty cool. A Yule implementation of the same thing, because why not? And this is fundamentally it. Stablecoin. Maybe we do a micro-lending next, how a lending protocol works. It's a bit more complicated, but at its core, a stablecoin is also a kind of a lending market, because you lend or you borrow this made-up stablecoin against your collateral, and it's basically a way to leverage up. But that's basically it. Thanks for tuning in, and see you in the next one.